Hi again. Adding and subtracting radicals. Continuation to covering the radical section from pre-calc 11. So square root of 28 plus square root of 175 is not simple. You're not going to just add the 28 and the 175. However, we have to change these to mixed radicals, and we hope to get like terms once we do that. So the first thing is 28. As I mentioned before, you look for what in here goes into 28, and it's obviously the 4. So I'm going to change the 28 into 4 times 7 plus the 175. I'm also going to look into here and see what goes into 175. I know definitely 25 goes into 175 7 times. Now, as I mentioned in the earlier lesson, when you look to change radicals into mixed radicals, you want to look right into here. If it's a square root, you look into these numbers. It has to be a number from here that you're going to use in here. Don't just use any random numbers. Why? Because you know the square roots of all of these numbers. And so when you go to this now, you go, okay, I know the square root of 4, it's 2, but I don't know square root of 7. It doesn't have a square root that's a whole number. So it just stays as a root 7 plus square root of 25, it's 5, but we cannot root 7 without a calculator. So just keep it as root 7. Now, if you look at these, the root 7s here make them like terms, and therefore you could add these two. Almost like 2x plus 5x gives you 7x. It's the same thing. 2 root 7 plus 5 root 7, it's 7 root 7. Another question now. Very similar, but we just throw in the x's in there to make it sound or look a bit more complicated, but there's nothing to it. It's just the same thing. So 5 square root of 8x. The 8, I know I could change into 4 times 2 since the 4 is a perfect square. And I'm just going to carry the x in there, and minus 3. The 18, I know 9 goes into 18, so 9 times 2. And I carry the x. Now, the only thing I know the square root of is the 4 here, so becomes the square root of 4 is 2 times 5 is 10. But the 2x, I don't know what the square root of that is. So I'm just going to keep it as 2x under the root there. Minus 3, or maybe just a square root of 9. The square root of 9 here is 3. So you multiply it into this 3 and you get 9. However, the 2x, you don't know what the square root of that is, so you just keep it as 2x. And when you add or subtract this from this, they are like terms since they have the same radical. So you just go 10 minus 9, which is 1 square root of 2x. So you don't have to write the 1 there because everything has a 1 in the front of it. So the answer is just 1 if you want, 1 square root of 2x. So this is the second example. We're going to give you a third example. So the next example, same thing, except a bit more. You have to do a bit more with this. So 3x, the 20, I want to break that down. It's going to be 4 times 5. And the x, I'm just going to keep it as x, minus the 24. I know 4 goes into that as well. So it's 4 times 6x plus the 45, 9 goes into the 45 5 times. So I'm just gonna, that's gonna be 9 times 5. Also the x cubed, since I'm square rooting and there's a 2 here, I'm gonna make it into x squared times x. And now I'm just gonna write this again. Square root of 4 is 2. You multiply the 2 into the 3, you get 6x. And the 5x, you cannot square root that, so you're just going to keep it as a square root. Minus the square root of 4 there is 2. And the 6x, you cannot square root, so just keep it inside. Plus the square root of 9 is 3. And the square root of x squared is x. And the 5 and the x, you cannot square root them, so just stay behind there. And now the only like terms you have here is this and this, because they have the x here and they have the 5x under the radical, so they are like terms. So 6x plus 3x is 9x, and the radical 5x, just don't add the radicals inside, don't say that's 10x or whatever, you know. Minus 2 root 6x, just carry that. And we'll go to the next example. So now we're going to add and subtract cube roots. Again, as I said earlier, we know the cube root of 8. We know the cube root of 27. We know the cube root of 64. I'm just going to make that a bit clearer there. Cube root of 8, cube root of 27. So if we look at this and we look at this perfect cubes, I know 8 goes into 16, so I'm going to change that into 2. Cube root of 8 times 2, since 8 goes into 16, minus cube root 54. We know 27 goes into 54 twice, so so I'm just going to write cube root of 27 times 2. And now the cube root of 8 is 2 times 2 is 4. And we still have a cube root of 2 that I cannot do cube root of. Minus cube root of 7 is 3. And I still have the cube root of 2 because I cannot cube root the 2. Therefore, now these are like terms. 4 minus 3 is 1. Cube root of 2. We're going to go to the next question. So now the last question we're going to do with the adding and subtracting radicals. These lessons are made to just give you an idea. Of course, once you look at what I'm doing here, you should go and practice from your textbook. Just look at the section that involves these kind of questions and practice more. But this is more of a preview guideline to what you're supposed to be doing. So again, the cube root of x to the 7, as I mentioned in my earlier lesson, that x to the 7, you break it into x to the 6 times x. So that's x to the 6 minus 2x. And the cube root of x to the 4, break it down into x cubed times x. And this, you cannot do anything about this one, so just keep it as 3x squared cube root of x. Why we change this x to the 6 times x? Because 6 divides by 3, and therefore, to give you 2, therefore I know the cube root of x to the 6 is x squared. So that's going to be x squared, but you still have the cube root of x, cannot cube root an x, minus 2, that's x cubed, cube root of x cubed is x. And the reason is just because 3 divided by 3 is 1, so it just gives you x to the 1. And since it's x, you multiply it into the x and the outside there, and it gives you x squared. And I still have the cube root of this x here that we cannot cube root, okay? And this one, you cannot do anything about it. Just simplify it as far as possible. And there. Now, if you look at these, all of them have x squares, and the radical is cube root of x for all of them. So all of these are like terms. Of course, there's one here, so just add them like you're adding like terms. So 1 minus 2 is negative 1, plus 3 is 2. So the final answer is 2x squared cube root of x. This lesson is done for today. See you next time. Stay safe.